What's up? What's up? It's your man, Jimmy Chan. Hey, today we're talking about transformation of functions. So these are common parent functions that we should know. In other words, stripping away all the other stuff, just plain Jane, simple as simple can be, right to the root of it. That's what a parent function is. All right. So you notice that these are all just nice and simple, no coefficients, nothing. All right. So that's what those are. All right. So you should know those functions because if they bring up something and you don't know what the parent function is, then you won't know where to go from there. So you kind of need to know what the parent function is. So before we get into transformations, what can happen in transformation? Well, transformation could be some kind of vertical, horizontal shift, meaning shift left, shift right, shift up, shift down. Some kind of shrink or stretch. It could be vertically, up and down stretch, up and down shrink, horizontal stretch, horizontal shrink, right? And then there can be reflections over the x-axis or the y-axis, okay? And the general formula that you're looking at is something like this, okay? And you're like, wow, this is really confusing. However, if you look at it simply, all right, if you notice what is actually attached to just the x and what is attached to f of x, right? So we already know that f of x is a y value. So then anything that's attached to f of x would just affect the y value, while anything that's attached to the x will affect the x value. All right. So with that being said, let's say I come up with a different function here. Let's call it h of x. And let's just deal with everything that would affect f of x, right? If I just left it as just f of x, what are the things that would affect this? Well, the two letters up here that actually affect it is the a and the d, okay? So those are two things that actually affect the f of x. And again, we know that f of x is the y value, right? So that means a and d affect the y value, right? Which means it's everything which is everything vertical, right? Makes sense? All right. So it's going to affect everything vertical. Now, if I change, let's say, a different function, I don't know, like j of x, right? And let's call that everything that affects the x. So you look in here, what's actually connected to x? Well, if you notice, it'll be the f of the b is connected, and the c is connected, right, to the x value, right? Because it's all within that parentheses, right? Because anything inside that parentheses is where we say, hey, if it's, anywhere there's an x, replace it with anything inside that parentheses. So b and c would actually affect the x value. So b and c affect the x value, which is everything horizontal. Okay, so there we go. All right, so let's see here. So you probably want to know, hey, how does it affect it vertically? How does it affect it horizontally and stuff like that? So, okay, so let's take a look here. All right, so let's just go in. No, you know what? Let's go with, let's deal with the vertical stuff and then we'll deal with the horizontal stuff, okay? So let's talk about vertical. So vertical was an A and a D. So let's talk about how A affects everything. Okay, so here we go. the A has several issues here, okay? So if the A is greater than 1, that is going to be a vertical stretch. However, if the A is between 0 and 1, meaning a fraction or a decimal that's less than 1 but greater than 0, that's going to be a vertical shrink. Okay? And if A is negative, then we would reflect over, and you're like, So the A is attached to the Y, right? So if the A went from positive A to negative A, it will reflect over the x-axis. Okay? So let's talk about the other part, D. How would D affect everything? Well, if D was positive, then we would shift up. Because again, vertically. If it's negative, we will shift down. Okay? So that's how everything affects vertically. Okay? So actually, let's do this. Let's bring this whole thing right here and shift it right over here under vertical. There we go. Now this way, cool part is that I can put down horizontal over here. And horizontal has B. So the B, same idea. If B is greater than 1, then it's going to be a horizontal shrink. While if B is between 0 and 1, then it's going to be a horizontal stretch. And if B is negative, then we're going to reflect over. So again, the B is affecting the X. So the X went from a positive X to a negative X. We reflected over the Y-axis. Okay? And then the other one is C. So if C is positive, then it's going to shift to the right. If it's negative, actually I should write down shift to the right. And if it's negative, it's going to shift left. Okay? So there we go. All right. So what are these graphs right here? That's probably where your question is. So here we go. All right. So I'm going to call this one right here dead center as the original. Okay, that's the original graph. So let's talk about what it means by a vertical stretch, vertical shrink versus a horizontal stretch and a horizontal shrink. Okay? All right, so let's do that really quick. Actually, you know what? Maybe is a good, no. Let's do this. Okay, I'm gonna put down vertical. I'm going to select these two graphs right here and shift it upward. Okay. And then this is what I'm going to do. So this right here, vertical means up and down, right? So if I was to shrink vertically, that means I'll get shorter, right? So if I get shorter, it'll look something like this. Not like that. It'll look something like this, right? Like I'm shorter. So this would be a vertical shrink. Right? While a stretch, same thing. If it was vertical, that means I'm getting taller. Right? So this would be called a vertical stretch. Okay? And so when I was in 8th grade, I was a vertical shrink. So that's why I look like a quarter. So I always told people that it was tall, but short. Tall meaning from left to right, short meaning vertically. So I was a vertical shrink. So therefore, my graph compared to the original graph would actually seem wider because I was shorter. But once I start growing and I had a vertical stretch, right? What happened was my body stretched as well, so I started looking a little skinnier, all right? So the vertical stretch actually made, compared to the original graph, actually looks narrower, okay? All right, so how about I put it this way? In parentheses, I would say this is wider. And with a vertical shrink, right? 0 less than A less than 1, right? For a vertical stretch, right? What do we know about vertical stretch? Actually, you know what? Can I fit that right in there appropriately? Vertical, yeah, stretch. Okay, so essentially this is narrower and A is actually greater than 1. Okay, so let's put it that way. All right, so over here, let's talk about, bring this back up over here. Let's go and draw, select original graph, put it in here, and then red. So this is going to be horizontal. Okay? All right, so let's talk about horizontal. So horizontal shrink means that from left to right, I'm going to shrink. So it's going to look something like this. Right? So that's a horizontal shrink. Okay, so from left to right, it came in. This is narrower. And what do I see here? For shrink, B is going to be greater than 1. Okay? While, if I was to go horizontal stretch, that's what happened to me in the last couple years. All right, that's why I'm starting to run. So there you go. So this is called a horizontal stretch. Okay, so this is obviously wider. And if you notice that this is when B is between 0 and 1. Okay, so if you notice here, what I want to point out to you is you can either remember these little intervals here, which one goes where, right? You can actually put it in your head vertically if that coefficient is bigger than 1, instead of at, let's say it's at 8 on your y value, now it becomes 16, it would make sense that it would, go up faster. So therefore it's a vertical stretch, right? So that's the way you want to look at it. And then over here, I want you guys to notice something. If you can think of the vertical stretch and the horizontal shrink as both those graphs are actually getting narrower, and if you notice that the interval for those two are exactly the same, right? So narrow, A has to be greater than 1, where B has to be greater than 1, versus the vertical shrink and the horizontal stretch became wider, if you notice that their intervals are exactly the same. So I guess for me, it might be easier for me to remember that graph is going wider. If it's affecting the X, I know it's horizontal. If it affects the Y, then I know it's vertical, okay? So that's how I would want to look at it, and that's what I was going to make a table of, but I think this is a better look of it. So if you want to, I would put it this way. Let me do it this way. Let me highlight the narrower with that interval versus the wider in their interval comparably, okay? So this way you can kind of see that difference there. And then now I can just go blah, 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 and that part is done. So you probably want to say, hey, that's a lot of information. How about some examples? So I concur. So that's what I'm going to do. So let's say that, I don't know, they can give you, now, please do not make this harder than it is because it really isn't that difficult, all right? So let's say they give you a point, negative 14, 4, okay? And they say, so this is part of f of x. And they say find, and they want you to find g of x is equal to f of x minus 3. Okay, so what does that mean? Well, what do you know about f of x? F of x is the y value, correct. So if f of x is the y value, I just wanted to take the y value, subtract 3. So what's going to happen is that my negative 14, 4 will now go to negative 14, 1. You're like, oh, why? Well, again, f of x is my y value. It says take my y value and subtract 3. So I took my y value, which is 4, subtract 3, and I get 1. That's all it is. Okay, so it really isn't that deep. All right, so let's keep on going. Let's say find h of x is f of x plus 3. So what you would do is you take the negative 14 over comma 4, and that's going to turn into negative 11 comma 4. Again, what was I asked to do? Take the x value, add 3. So I took the x value, add 3. And that's all it was. All right, let's say j of x is equal to 2 f of x. All right, so I take negative 14, 4, and that's now going to become negative 14, 8. What's f of x? That's a y, so 2 times y. Okay, so I got 2 times 4. So I get 8. Voila. Okay. Let's say t of x is equal to f of 1/2 of x. Or heck, negative 1/2 of x. So I take the point, and that's going to become what? Okay, because again, this is taking the x value and multiply by negative 1/2. So negative 1/2 times negative 14 will be positive 7. There we go. Okay. Initially, you guys were thinking, wow, this is going to be so hard, but it really isn't, right? All right, so next problem. So next problem, let's talk about a graph. Okay. So let's see here. Let's say that g of x is equal to negative f of x minus 1 minus 4. Okay? And what they have here is a graph. So I'm going to put the graph right here. I'm sorry. File, and this is my plain old graph paper. Let's take that graph paper. Excellent. Thank you. Okay, so this is what they have here. And what they have drawn here is this. Let me see if I can mimic it. I think there was a point at negative 6, 0. Zero, 4, negative 2, 4, and I'm just going to call it 2, 2. Why not? Okay, so let me draw some lines here. Going from there to there, there to there, and there to there. So something simple like that, okay? So there it is. So what do I do? Now, when you deal with this, you're still going to have to go through the order of operation. Okay, so maybe I should put it way up here. Order of operation. Okay, it still applies. Meaning, so if you look at this, what does that mean? So typically we work with parentheses first, right? So when we go into parentheses, we get into this bx minus c. So what would we do? We would go in to the deeper parentheses within the parentheses and go through the process again, right? So that means we would do the x minus c first. So in other words, we would do the c first, which is shifting left to right, or left and right. And then we would deal with a b, because that would be multiplication. And then we would, which is shrinking in and stretching horizontally. And then after that, we get outside the parentheses. What do we do first? We have to multiply or divide before we add or subtract. So that means the a has to go in first, which is a vertical shrink or stretch. And then we can shift it up and down with the d, okay? All right, so here we go. So order operations. Inside the parentheses says minus 1. So let me go do this. Let's say that this is my first Okay, that's my first thing. So I'm gonna put down here, step 1. So that's the first thing I have to do. So that means I'm shifting everything to the right 1. So this point here is going to shift this way, this point here is going to shift this way, this point here is going to shift this way, and this point here is going to shift this way. So great. Now I have a line this way, a line, shoot. Why didn't someone tell me it's too long? There. And then one more from here to here. All right, so there's my shift to the right. Okay, so shift right 1. Okay, so what's step 2? So is everything inside done? Yes. Okay. All right, so step 2. So you're like, what do I do next? What do you guys think? Is it the negative in front of f of x or the subtract 4? It's a negative because dividing comes before adding, subtracting. So I'm subtracting the y value. So I'm making a positive y value become negative y values, right? So I'm going to reflect over the x value, x-axis. So, okay, so now I'll reflect everything over the x-axis, or better yet, I'm changing all the y values. So same thing as change all y values, or I should say, you know what I should call this? Because it's negative, I should just say negate all y values. Okay? So if I take all the y values and negate it, where is it going to be? Well, this y value is 0, so it stays 0. This y value here is, what is it, negative 1, 4. So it's now negative 1, negative 4. This one is 1, 4. Now it's 1, negative 4. And this is 3, 1. Now it's 3, negative 1. Okay. So let's bring the business of the lines back. There's that one. Then that one. And then there's this one. There we go. So that is step 2. All right. Step 3. Well, step 3 is now this right here. Minus 4. So that means what? A shift down 4. Okay. So now everything is going to shift down 4. Again, it's the y value. So I can just call this to subtract 4 from all y values. Right? Okay. So this y value is 0, so it's now negative 4. This y value is negative 4, so it's negative 8. Negative 4, negative 8. 3, negative 1. Negative 1 would be now negative 5. Okay. So my green graph is my final graph. All right, so you see all the shifting that's going on, right? So from there, let's see if I have anything else I want to show here. Okay, the last thing I want to show is this. So last example, so let's say I have something like h of x is equal to -2, negative x plus 4 squared plus 5. So first thing I have to do is identify the parent function, okay? So first, parent function. So you will go back up to this list here, which as you do them, you're gonna be like, oh yeah, that's all it is, right? So you go, okay, I see a square sign in there. Which one has a square sign? There's only this one, but the square is in the denominator, right? This one right here only has a square in the denominator, so that's not it. So there's only one other one, and that will be the quadratic, okay? So, okay, you're like, okay, great. So I know what the parent function is. That is the quadratic, which is f of x is equal to x squared, okay? Awesome. So done. So now, what is the second thing I have to do? So I'm taking that parabola and I have to go through everything here. Okay, so order operations, I have to go into the parentheses. Well, now this is different from what I explained before because there's no parentheses within the parentheses, right? So actually, the first thing is going to be this negative sign here. Is affecting the x value, so it's making a positive x become a negative x, so I'm reflecting over the y-axis, right? So I am also negating all x values, okay? What is the second thing next thing I should do, which is the third thing. So the third thing here is now going to be this piece right here. Okay. Now be careful. Be careful. Because up here, this says x minus c, right? So x minus c. So that means I'm going to, it's actually minus a -4. So that c is actually a -4. So that's why I'll be shifting left. So shift left 4. Okay, so I'm gonna subtract 4 from all x values. Okay, again, it's attached to the x. Okay. All right. Show what is next after that. So let's go green. Whoa. Step 4. So what's after that? So everything inside the parentheses is taken care of. Now I go outside, and it is gonna be me. No. Okay, so the -2, what does the -2 do? Right? So negating it, what happens? Right? I reflect it over what's being affected here. Is it the y value, the x value? It's the y value that's getting affected. So therefore, if I went from positive y to negative y, I'm reflecting over the, so reflect over the x-axis, right? So I'm going to negate all y values. And what else? What does a 2 do? Okay, what does a 2? So 2 is affecting the y, right? So if it's affecting the y, what is it doing? is doing a vertical stretch. So essentially all you're doing is multiply all y values by 2. Okay, so that's what the -2 would do. And what is last? Let's see here. Might as well use something like a purple. So step 5, which is this part right here. Okay, so what does that do? That's going to shift up by 5. So in other words, I'm going to add 5 to all the y values. Oops. Okay, so that's what I would be doing. All right, so if you notice that I went from inside out, I gotta be careful of this piece right here because in the original equation is x minus c, so I gotta be careful with that. All right, well, this is exactly what you would be doing, and with me writing it out is the same thing as what you would be doing, as you're creating the graph, which is exactly why I did it here as well. So hopefully this answers all your questions. If you have any questions,